Hello viewers, in today's session we are going to discuss the proof of the famous Euler's reflection formula. So the Euler's reflection formula, it goes like this, that is the product of gamma n and gamma 1 minus n is given by pi divided by sine n pi, right? So here we are going to prove Euler's reflection formula with the help of two concepts, right? The first one is the Weierstrass definition of gamma function, and the second one is the infinite product representation of a sine function, right? So here first we'll use the definition of gamma function given by Weierstrass, and then we'll use the infinite product expression for sine theta. So let us start. Now the definition of gamma function as defined by Weierstrass is given by this expression, that is gamma n is equal to n times e raised to gamma n, where this gamma is the Euler's constant, and here we have the infinite product, that is from m is equal to 1 to infinity, and here we have 1 plus n over m, and e raised to minus n over m raised to minus 1, right? So here this expression gives us the definition of gamma function, that is gamma of n given by Weierstrass, right? So now let us replace this n by minus n in this expression. So we have gamma of minus n is equal to minus n e raised to minus gamma n, and here we have the infinite product, that is from n is equal to 1 to infinity, and we have 1 minus n over m and e raised to plus n over m, and here we have minus 1, right? So here we'll take this expression as equation number 1 and this expression as equation number 2, and here we have the positive sign because we are replacing n by minus n, right? So here we have the definition of gamma function given by Weierstrass, and here replacing this n by minus n in this expression, we have obtained this equation, right? And this gamma is known as Euler's constant, and the value of gamma lies between 0 and 1, right? And the approximate value of gamma is given by 0.577. So now we'll use the definition of gamma n as given by Weierstrass, and the infinite product representation of sine function to derive this Euler's reflection formula. So now let us find out the product of gamma n and gamma of minus n. So let us multiply these two equations, right, to get this product, that is gamma n and gamma of minus n. So multiplying these two equations, we get gamma n, then we have gamma of minus n, and here we have n e raised to gamma n, then we have here minus n e raised to minus gamma n, and then we have m is equal to 1 to infinity, and we have 1 plus n over m, and here we have 1 minus n over m and e raised to minus n over m, and here we have e raised to positive n over m, and here we have minus 1, right? So what we have done here, we have multiplied these two equations, right? So now we have gamma n, gamma minus n, and here we have minus n square, and these two terms get cancelled, and similarly here these two terms get cancelled. Here we have minus n over m, here we have n positive n over m, and now we have m is equal to 1 to infinity, and here we can apply the identity, that is a plus b, a minus b, that is 1 square minus n square over m square. So we have 1 minus n square over n square, right? And here we have minus 1. So let us call this equation as equation number 3. So now here we can also write this equation as minus, and here we have n raised to minus 2, and we have m is equal to 1 to infinity, and 1 minus n square over m square, and here we have minus 1, that is we can also write it as minus 1 over n square, and m is equal to 1 to infinity 1 minus n square over m square, and here we have minus 1. So the product of gamma n with gamma minus n is given by this expression. So now let us make use of the well-known infinite product representation of sine theta. Now sine theta over theta is given by this infinite product representation, that is m is equal to 1 to infinity, and here we have 1 minus theta square over m square and pi square, right? And here if we replace theta by say n pi, then this expression reduces to sine n pi over n pi, and here we have the infinite product representation, that is from m is equal to 1 to infinity, and 1 minus here we have n square pi square, replacing theta by n pi, and here we have m square pi square. So this is m is equal to 1 to infinity, and we have 1 minus here pi square and pi square get cancelled, and we have n square over m square, right? So now if we take the reciprocal of both sides, then we have n pi over sine n pi is equal to here we have m is equal to 1 to infinity, and we have 1 minus n square over m square, and here we have minus 1, right? So we have taken the reciprocal of both sides. So here we have n pi over sine n pi, and here we have the inverse or the reciprocal of this infinite product representation, right? So now here we have the product of gamma n and gamma minus n as this expression, right? So here we can now replace this term by n pi over sine n pi. So now the product gamma n with gamma minus n is given by minus 1 over n square, and here this term is replaced by this one. So here we have n pi over sine n pi, right? So now we have gamma n, gamma minus n, and here we have now this n and this n get cancelled. So we have minus pi over n times sine n pi. Now let us make use of this important result, that is gamma n plus 1 is given by n times gamma n. So now if we replace n by minus n, then this expression reduces to gamma minus n plus 1, and here we have minus n, and here we have gamma of minus n, right? So from here we can now write the value of gamma minus n, that is minus 1 over n, and here we have gamma minus n plus 1, that is minus 1 over n, and gamma 1 minus n, right? So now let us substitute the value of gamma minus n equal to minus 1 over n gamma 1 minus n in this expression. So here we'll write gamma n, and gamma of minus n is replaced by this expression minus 1 over n gamma 1 minus n, and here we have minus pi over n times sine n pi, right? So now we have minus 1 over n, and here we have gamma n times gamma 1 minus n, and here we have minus pi over n times sine n pi, right? So now we can cancel this negative sign with this one, and here we have n and n get cancelled, and we get the desired Euler's reflection formula, that is gamma n times gamma 1 minus n is equal to pi divided by sine n pi, right? So viewers, this is how by making use of the definition of gamma function given by Weierstrass and the infinite product representation of sine theta, we can easily prove Euler's reflection formula. So now using Euler's reflection formula, we can also derive some important results, right? So let us start with this integral which is equal to the beta function, that is beta m comma n is given by this integral, that is 0 to infinity x raised to n minus 1, 1 plus x raised to m plus n, and here we have dx. Now let us replace m plus n by 1, so that m is equal to 1 minus n, right? So now this expression it takes the form, that is beta 1 minus n comma n is equal to 0 to infinity, and here we have x raised to n minus 1 and 1 plus x raised to 1, because we are now replacing m plus n by 1, and here we have a dx, right? So now here we can use the relationship between a beta function and gamma function, and we know that beta m comma n is given by gamma m times gamma n divided by gamma m plus n. Now m is 1 minus n, and here we have n, and here we have gamma 1 minus n for m, and gamma n, and here we have gamma 1, because m plus n is equal to 1. So now the value of gamma 1 is equal to 1. So we have the beta function equal to gamma 1 minus n times gamma n. And from Euler's reflection formula, this product is equal to pi divided by sine n pi. So we have the beta function equal to pi divided by sine n pi, right? But we have seen that from this expression beta 1 minus n comma n is equal to this integral, right? So taking these two equations, we can now write the value of this integral, that is 0 to infinity x raised to n minus 1 over 1 plus x dx is equal to pi divided by sine n pi, right? Because here in these two equations the left hand sides are same, right? So the value of the integral 0 to infinity x raised to n minus 1 over 1 plus x dx is equal to pi divided by sine n pi. So this is how, by making use of Euler's reflection formula, we can find out the value of this integral equal to pi divided by sine n pi.